Hello and welcome to Linuxhint YouTube channel. Today in this video we are going to talk about functions in C programming language. We are going to cover topics like what are functions, why should you use functions, what is function declaration, definition, and how do you invoke a function. Without any further wait, let's get into the video. First up, what are functions? Well, functions are a set of instructions that are enclosed within parentheses to achieve a particular task. Just by this definition, you are already aware that a set of code or set of instruction put together by the programmer enclosed inside curly parentheses whose only objective is to achieve a particular task. But you may think, why should you even use functions in the first place? Well, as a programmer, we want to write some code that we can reuse again and again in our project. But that is just one of the pros of writing functions. Functions actually provide us with three main benefits. The first one being abstraction, the second one being modularity, and the third one being reusability. When it comes to reusability, it is the most prominent features of writing a function. You can reuse the code no matter how many times you want to use it. If we talk about modularity, as a programmer, we want to divide and conquer. We want to break down a big problem into smaller modules or smaller problems and then tackle those small problems one by one. The last one is abstraction. Well, abstraction is that we can use a function written by someone else without actually worrying about how it interacts with the operating system or with the compiler. We just have to know what are the inputs required for that function to work and what is the output type that we are going to get from that function. Well, that was why should you use functions. But how do you actually define, declare, and invoke a function? Or what even are those things? Well, let's talk about function declaration. A function declaration is a statement that tells the compiler about a function's name, return type, and parameters. Parameters are the inputs that are required for the function to perform a particular task. While the function definition is where we actually code out the functionalities or the working of that function. We can say a function definition provides the actual body of the function. A function declaration looks something like this. First off, we have the output type, the return value of the function that the compiler should expect, followed by the identifier of the function. Just like we name our normal variables, we give a name to a function as well, followed by inputs enclosed within the round parentheses. Now, these inputs are called parameters during the function definition and called arguments when we are invoking the function. These are the inputs that must be given to the function to provide or to compute the desired results. At the end of the function declaration, there is always a semicolon in C programming language. Coming to code, to explain functions, we are going to simply create a new function that would help us calculate the area of a rectangle by taking some inputs from the user. Now these inputs are going to be the length and the width of the rectangle. So for this function, I want to return an integer value. So I'm going to write integer and then I'm going to name the function as area of rectangle. And within the round parentheses, I'm going to define the inputs. My first input is going to be of the data type length, integer with the name length. And the second input is also going to be integer with the name width. And just like that, I'm going to close off or end off my function declaration with a semicolon. What happens is that the compiler goes inside the main file and knows that, okay, at any point within this project or within this file, if a call is made to this particular function, then I know where this particular function is placed at. So rather than trying to find where this function actually is, I can simply just go over to this particular memory address and start computing my desired results. Okay, coming to our main function, what we want to do is we want to get some inputs. But before that, remember, we still have to define that function. So our function was area of rectangle. And rather than semicolon, I'm going to place curly braces. The curly braces would tell us that this is the body of the function. So this is pretty basic, pretty generic. We want to return some value because we have already defined that this function is going to return an integer value. And that value is going to be the area of rectangle, which is length into width. So I'm going to simply write a simple line, which is return length multiplied by width. This is the function declaration, which tells the compiler that we're going to use a particular function of this name, which will be placed somewhere in the memory. And when that call is made, you need to come over to this particular address and start executing these following lines. Okay, let's get back to our main function. So our program pointer comes into the main function. What we want to do is that we want to prompt the user that he needs to enter some values. Enter the length of the rectangle. And then I can scan these values and place it inside some variable. I also need to create those variables as well. So I'm going to create length and width. Similarly, I'm going to get an input for the width. And then I'm going to create another variable. I'm going to call it result. And for the value of this result, I'm actually going to fetch a value from this function. So I need to invoke it. To invoke a function, you simply write the name of the function, and within the parentheses, you pass on the required arguments. So in our case, the first argument was length, and the second one was width. At the very end of the program, I want to show this result to the user as well. So the area of the rectangle is okay. Before executing this program, let's just dry run this once. So the program pointer comes into this file, sees a function declaration, knows that there is going to be a function named this, which is going to take these particular inputs, and this is the type of output that I should get. The function then goes inside the main function, creates two variables, shows a prompt to the user, gets an input, shows another prompt to the user, gets another input, creates another variable, but for the value of this variable, it is going to get out of this main function into this area of rectangle function to execute this particular command and then return the value back to this position. And in the last printf statement, I want to show the result stored inside this variable as well. Let's try executing this code. Enter the length of the rectangle, we will enter 5, and for the width of the rectangle, let's input something like 3. And the area of rectangle is 15. We have only used this function once, but what if we want something like integer result 1 is equals to, I'm simply going to copy paste these lines, and for the values I'm going to print out like 2 and 5. So we're actually using this function again. Or what if we want to use it a couple more times and simply change the name of the variable R2, R3, R4 and R5. So what we are doing over here is that rather than writing that function again and again, we can just simply call that function no matter how many times we want it. And to showcase this, I'm simply going to write a print statement. I'm going to have like %d/n. I'm going to copy paste this a couple more times, 2, 3, 4 and 5. And I'm going to pass on values like R1, R2, R3, R4 and R5. And let's even tweak out some of the values just so we get some different results. So if we run this program now, this should give us different areas of rectangles, or I should say areas of different rectangles. Just like we have 10 for the first one, 30 for the second one, 20 for the third one, and so on. The bottom line is that you can write one function and use it a million times. So that is how you declare, define, and invoke functions in C programming language.